A question a day, day 13. Prove by induction that for all integers bigger than or equal to 1, 2 plus 5 plus 8 plus up to 3n minus 1 is equal to a half n 3n plus 1. Okay, so just make sure I've got a pen that's going to work. Sorry about this. Okay, let n equal 1. So our left-hand side is equal to 3n minus 1. 3 times 1 minus 1, which is 3 minus 1, which is 2. And the right-hand side is equal to half of 1, 3 times 1 plus 1, which is a half times 1 times 4, which is 2. Left-hand side equals the right-hand side. Therefore, statement true for n equals 1. So it's true for our base case. Okay, assume statement true for n equals k. So that is 2 plus 5 plus 8 plus ... plus 3k minus 1 is equal to a half k 3k plus 1. Okay. Now we want to show that it's true for k plus 1 if it's true for k. So, hold on. I do this every time. I'm just going to create a bit of room. Okay, let's back up here. Okay, so we want to show statement true for n equals k plus 1 if true for n equals k, i.e. 2 plus 5 plus 8 plus ... plus 3k minus 1 plus 3k plus 1 minus 1 equals a half k plus 1, 3k plus 1 plus 1. All right, so the left-hand side of this is your 2 plus 5 plus 8 plus ... 3k minus 1 plus your 3k plus 1 minus 1. That gets you up to your k plus 1. Now, we've already assumed this, that you can say that anything from 2 plus 5 plus 8 all the way up to that, up to k minus 1, which is that, can be replaced with a half k, 3k plus 1. So that's what we're going to do. We're going to make that replacement. That's a half k, 3k plus 1 plus 3k plus 1 minus 1, which is now we're wanting to make it look like this here. Now you could have simplified the stuff that I've just arrowed to make life easier to look like that, of course. Okay, and you can meet halfway as long as you accurately do. But let's just see how we go making it look like that. It's one long statement being multiplied rather than two. So I'm going to actually see if I can get a factor of k plus 1 out of both of these. All right, so this is a half of k, 3k plus 1, plus a half of 6k plus 1 minus a half of 2. So I'm just getting the half out, right? So that's a half of, and I've got 3k squared plus k plus 6k plus 1 minus 2. That's having pulled a half out. There's lots of ways to go about this. You just got to unfold it as your algebra goes. But this is 3k squared plus 6k and k, 7k plus k 6 plus 6 minus 2. 6k plus 6 minus 2, yep, that's right. Okay, now, just making it look nice, that's 3k squared plus 7k plus 4. Now, I'm thinking that because I'm trying to get k plus 1, where that asterisk is, k plus 1 probably goes into this here, all right? But what you're wanting to do is your normal factorising of a quadratic like that, you know, so 3 times 4 is 12. So you want a times b to be 12 and a plus b to equal 7. Oh, it is 3 and 4, all right? So when I'm going about factorising that, I've got 3k squared plus 3 plus 4k plus 4. All right, so that's 3k into k plus 1 plus 4 into k plus 1. So that's a half of k plus 1 times 3k plus 4. And then, having factorised that quadratic, I'm going back up to the asterisk. I've got my k plus 1. I just want 3k plus 1 plus 1. So, k plus 1. This is 3k plus 3 plus 1. Half k plus 1. 3k plus 1 plus 1. K plus 1, brackets, 3k plus 1 plus 1. Yeah, that works. That is a half k plus 1, 3k plus 1 plus 1. Okay, equals the right-hand side. Therefore, true for k plus 1 if true for k. And then you just need to conclude. So, true for k plus 1 if true for k. Since true for n equals 1, comma, then true for n equals 2, etc. Therefore, by the principle of mathematical induction, the statement is true for all n bigger than or equal to 1, n being integers, i.e. 2 plus 5 plus 8 plus 3n minus 1 is equal to a half n 3n plus 1 for n bigger than or equal to 1.